Dr. Brian Goldiez is the Deputy Director and Research Associate Professor at the University of Central Florida's Institute for Simulation and Training. UCF is the largest university in the United States with over 60,000 students. He has been involved in various aspects of computer-based training for over 40 years, having worked for government, industry, and in academia for 25 years. Brian publishes and consults regularly. His focus has been on using technology to optimize human performance, with recent efforts orientated towards dynamic load balancing in massive multiplayer online games, fine motor motion tracking, distributed simulations, and augmented reality. Brian has undergraduate and graduate degrees in engineering and was the first recipient of a doctorate in modeling and simulation from UCF. Brian, it's my great pleasure to welcome you to Barcelona. The floor is yours.
Okay. Thank you. And thank you for inviting me to this conference. So let me commence and we'll get you back on time. But I'd like to leave a couple minutes in case there's any questions. So if you have some, we'll hold those till the end. So a quick overview of the presentation. I always try to give some background, personal orientation so you know where I'm coming from. Ecosystem components, some case studies that we've experienced, and hopefully to share with you on moving this whole field forward. And then some ideas on how to move the community, continue to move it forward, not saying that it's not moving right now, and a call to action. So as Alan said, I work at a large university. At least in the United States, a fairly unknown university because there's a lot of universities in Florida. But at the institute I work at on the right-hand side, there are, let me just move forward. At our institute, everything we do is multidiscipline, everything. It might have an engineering bent, but there's human factors or educators, or it might have a very human factors or training orientation, but then there's always technical people. And therefore, we have a highly interdisciplinary staff. Psychologists, computer scientists, the normal cadre, but also some other fields that you might find unusual. We have an anthropologist. She was interested in, or is interested in, cultural differences in virtual environments and computer-based training. We have a historian. She does a lot of work in modern history. In the US, for example, at Kennedy Space Center, they tear down launch platforms, so she's interested in preserving those digitally. She's currently working on a project on the TWA pavilion at JFK, which is going to be airport, which is going to be converted into a hotel. And actors, and I'll mention actors, but remember actors because I'll get to them in a little while. So what is simulation? We break it at our university into two pieces. Physical science-based, process models, physics, chemistry, biology. Physical models, we do 3D printing and do time and motion studies. But at the institute that I work at, we're mainly interested in human-centric simulation and gaming. There's always a human in the loop. There's either a human in the loop, or we're modeling human behavior, or we're building avatars with a focus on knowledge and skill acquisition. That's the main focus of the place I work at. Traditionally, there were two branches of science, experiment and theory. But a few years ago, the then head of the National Science Foundation said simulation is really a third branch of science, combining theory and experimentation. That was very good for us from a selfish point of view. But again, this field is a melding of fields. And actually, the military in the US coined three types of simulation: live, virtual, and constructive. Live simulations are real people in real situations. Think of laser tag. Virtual is real people in simulated situations, virtual reality, flight simulators. And then constructive simulation is simulated peoples, things, and situations. Computer-based board games. SimCity would be an example. But again, I want to emphasize at least that the emphasis of our work at our institute, again, always involves a human and or modeling of human behavior. So why do we want to simulate? Lots of things are expensive to produce, too expensive, so we want to model them in a computer, where safety is a consideration. In the training world, we oftentimes don't want repeatability because we want to test you. And so we want different situations coming to you in a pseudo-random order. But in other situations, we want repeatability. We want to look at new designs and trade-off pieces in those designs. For example, we're doing some work for the Nuclear Regulatory Commission in the United States on designing new nuclear power plant control rooms. In those cases, it's not a game. And so we want to look at different screen designs and different layouts and see what works best for the operators. By the way, capitalizing a lot on what's being done in Europe, because Europe is ahead of the United States in nuclear power plant design. Also, we want to simulate when, for high consequence events, healthcare. We'd rather practice in the virtual world than practice on real people, or before we practice on real people. To visualize concepts that cannot be otherwise visualized, to rapidly explore new efficiencies. There's a lot of work being done. Siemens has a large facility in Orlando, and there's a lot of work done on looking and interacting with new turbine designs. Rapidly explore new methods, for example, in manufacturing, forecasting, and others. So I pulled this from a book at the bottom. It's called Computer Games and Instructions. And I can leave this presentation with anyone. But in simulations, we sacrifice entertainment in favor of reality. The work we do is very scenario or task-oriented, and the emphasis is on completing a task. It's not always interactive. And the focus is on rule, accuracy, and being detailed. And not all simulations are games. On the other hand, games sacrifice reality in favor of entertainment. We do things that don't behave to the laws of nature. Story is an important component. The emphasis oftentimes is on competition, and it's necessarily interactive. And the focus is on rule and clarity and being stylized. All games, in my opinion, are simulation. And same with these authors. So what's serious games? I poked around, and you ask a number of people and you come up with a number of different answers. I think it's the items in red. There are scenarios and tasks in many serious games. If you're serious, there should be an emphasis oftentimes on completing a task before moving on to something else. And the focus is on rule and accuracy base. But we will sacrifice reality in favor of entertainment. Story is extremely important. It needs to be interactive. And all games are simulations. But an important point that I want to emphasize, in my opinion, is serious games need to be engaging. We want people to return. So we need to continue working towards a stronger strategy to make games, virtual reality, augmented reality, more serious. Because again, as the editors from this book said, People learn from games, but can we design games where people learn what we want them to? So we want to do work ahead of time, not afterwards. So I mentioned that I'm interested in an ecosystem. So an ecosystem includes all of the living things, plants, animals, in a given area interacting with each other, and also with their non-living environments, weather, earth, etc. So for our purposes in this talk, an ecosystem for serious games includes all of the organizations and infrastructures in a given area, interacting with each other and also with their external environment. And I'll explain more as I go through this talk. In an ecosystem, each organization has its own niche. So, what additional skill sets are needed to create successful serious games today? And I want to emphasize the word successful. So, on the left side, someone has an idea and engages subject matter experts. And that's a great thing about universities. And a source of support to make the idea a reality is generally a university or a nonprofit or a small and medium-sized enterprise. A development team that too often consists of programmers, web developers, and content experts. In the work we do in Orlando, it's oftentimes instructional designers. And you always need some infrastructure, hardware, software, test device to see that your code works and that it's kind of moving in a direction that you intended. But we also need an agile, interactive development process because much of what we do oftentimes is trial and error. So we need a way to build something real quickly, see how it works, and then modify to reach an end state. We also need, and I'll mention why, a market assessment and a marketing group. At least in the States, a big part of serious game development is moving that development from the laboratory to a commercial enterprise. So we need to work with business people to do that. At least where I work, I'll explain what we do, but in my organization, we don't have that organically. We're developers and experimenters and researchers. We also need to have some usage and utility assessment that's immediate. Is this working? And also longitudinal over time. Is this particular serious game going to have what we call legs to it? Is it going to persist over time? Subject matter experts in all these fields are important. A technology transfer and maturation process is also needed. And then focus groups. And I harken back because I guess yesterday Apple introduced the iPhone 7. And I remember Steve Jobs said he never used focus groups, never. But he was a unique individual. And I dare say that at least where I work and live, we try to use focus groups because we're not as innovative as he was. So I think focus groups are an important part of what you're trying to do to see if it works. So in addition, for broadening adoption, and I'll mention each of these, is validation, culture, and business case. And let me touch on each of these for a minute because I think they're really important. I've seen in my organization that we build serious games and they're cool or they seem to serve a need, but in the end, do they really? So there needs to be somewhere along the line a validation study to say, is what the intent of the game meeting the intended audience's needs? There's also an issue, and I'll talk about this in a little more detail, of culture. I've seen programs where, and I'll mention one that we did, where a game-based system was developed for people doing physical therapy. But the users of that were of a different generation, and they were shied away from computer-based systems. So they cheated. They would look outside of the virtual reality and didn't see anything. So one needs to be sensitive to the culture of the developers and the culture of the intended audience that you intend to provide this service or this product to. And that's a really, really hard thing to do. And I'm going to touch on one, actually, that we're just in process of doing right now, game-based, for the military. And then if you want to build a product, which is the U.S. way, you need a business case. You need to be able to justify that what you're doing in the laboratory is going to be able to move out and somebody's going to be able to build a business around this. So let me, in light of these three items, let me talk about some programs at our university and what they're doing good and what they're not doing not good, but just are incomplete. So I mentioned that we have a project for the military, and this project is going on right now. In the top left, in the top of this picture, are full fidelity flight simulators that the U.S. Army uses to train helicopter pilots. Airlines use them too. They're $10 to $20 million a piece. And in the bottom left and the bottom center are two different game-based systems. The one on the left is built on a thing called VBS3, and the one in the middle is Microsoft Flight Simulator. The one on the right is a simulator in between the game-based ones and the full ones that move around. It's called reconfigurable training device, so it can simulate many different types of helicopters. So what the Army was interested in is they hear all this stuff about game-based systems, and a lot of the young aviators are used to playing video games. Can we not substitute for the top one, but can we maybe maximize the useful time that somebody spends in these? The top simulators cost $500 an hour to operate. So we've done a study of accumulating data with pilots. So we've put one group through the system on the right in the morning, and they run a mission, and they have to maneuver around and pick up injured people. And we put them through an analogous but different mission in the afternoon. We'd like the top to be a real helicopter, but we can't get access to the real thing. And we've done the same thing on the one on the left, because the military is getting ready to make a large investment in this VBS-based game, or Microsoft Flight Simulator, which is no longer available, but there's other ones available that are one 1/100th of the cost of the one on the left. So we've run about 60 pilots through these. We've accumulated data, subjective data, and we've also accumulated physiological measures, heart rate variability, galvanic skin response, and EKG. We had wanted to do EEG, but the military guys don't want anything on their head. So we do what we have to do. And we have some algorithms that we are currently munching on this data, and we'll report out both to the military and in appropriate conferences and forums. I mentioned that we did some work in virtual reality. This was not game-based, though. This was several years ago, and we were interested in people who had had traumatic brain injury. And this gentleman with the goggles on had a traumatic brain injury, and his wife would say, Blair, go in the kitchen and get me a cup of coffee, and he'd come back with a ham sandwich. So things didn't quite connect. So what we did was we built Blair's kitchen in green screen. So some was physical and some was virtual. And we textured Blair's kitchen with things that he was familiar with. And the issue was, can Blair learn? And the answer was yes. But there's a but. There's several buts on this. And this is where I say that, the full piece needs to be worked on. One is, this was a study of one person. So does it translate to other people? I don't know. Secondly, a month after Blair does this, does it really make a difference, or has he forgotten and we're back to where we started from? I don't know. One of the issues with doing studies such as these is access to a population and going through institutional review boards, and especially in the U.S., certain hospitals, and for good reason, are sensitive about allowing people who are being treated to be exposed to these things. And this guy also cheated. So we talked about cultural things. He would always look underneath, lift the goggles and look underneath. And we would tell him not to, but, he did it enough times that we weren't quite sure if we were getting what we needed to. But the point is that something was there, and we thought it had some further studies should be done. The group that does this work we have a group called Engage to Innovate in our institute. And they do virtual environments, mainly inexpensive ones, built on game-based engines, oftentimes Unity or Unreal, and several projects. One is in the upper left. We were interested in exposing children to Florida has a very sensitive ecology, and there's a lot of development in our state. So the interest was to have young children look at building developments near the Florida Everglades, and what would be the impact if a hurricane came through, et cetera. So we built this, and under sponsorship from the National Science Foundation, and placed it in the Science Museum in Fort Lauderdale. And this was an interesting project from 2 points of view. One is it was exposing young children, but two, kids like to see if they can break the game. So we would have focus groups of children come in and try to break the game, because we knew once it's shipped to Fort Lauderdale, we can't have somebody there and it needs to be repairable. So we made lots of changes. The system in the lower left is being done with our College of Health and Public Affairs, and again, built on Unity. And it's the university wants to provide master's degree programs in social work. Right now in the U.S., you have to do field work. But if the educational part is done online, how are you going to do field work? So this is a virtual character that we built for the Veterans Administration. And the student needs to interrogate that patient and find out what's wrong so that they can direct him to the right part. We have a doctoral student working on doing this work, and he's built the system and is now validating the system, or will be this fall, with social work students and other professors. I'll just touch on one more. In the right are a firefighter We've been, and I assume you have here, been very fortunate in, there's a lot, buildings are better constructed, there's a lot fewer fires than there used to be. So if in the United States or in Orlando, the first person on the scene is in charge of the fire, directing people on what to do. But they don't get much practice. So we built a very simple virtual environment where the firemen can, through hand motions, direct, you go over here, look, the fire's grown over there, and it's interactive. And we've deployed this. We don't normally build products, but we've deployed this to a local community college. Let me just touch on some of these in the interest of time. Let's go to the fair. National Endowment for the Arts built a very simple game-based system to teach children science, technology, engineering, and math by recreating a part of the 1964 World's Fair. And they can navigate and need to solve certain problems going through there. We're also doing currently some work in augmented reality research with a lot of it focused around the HoloLens. But the interesting thing is in the lower right, we built a physical virtual avatar. And the idea for this is that sometimes people have had disfiguring events that have caused disfigurement, and they might want to interact with society, but are self-conscious about interacting. So we built, you could put your face on the avatar, your previous face, and you can interact with this. We put this in our lobby just to see how people would respond. So there's Wizard of Oz, there's somebody behind the scenes, which could be the person who's been injured. Probably the most successful program we've had is a program called Teach Live. This was funded by the Bill and Melinda Gates Foundation, and it's to teach teachers classroom control. Let me briefly go over this is cool stuff. So this has a bit of virtual reality and a bit of human interface. This is originally started because teachers in the United States who begin teaching in inner cities have a huge dropout rate. The teachers do. They switch jobs. So we were interested in a screening mechanism. If you were a student in education, could we screen students that might be prone to stick it out and some that weren't? But this grew into something else. So the avatars, we create the avatars, and they basically have a small amount of AI. So they'll twidget around and do certain things. But using Microsoft Connect, as the teacher approaches the avatars, so they're on a large screen television, the avatar comes to life. And there's a puppeteer. There's somebody in our laboratory who controls that avatar. And it might be somebody who's always raising their hand, or it might be somebody who's disruptive or somebody who's shy. If the puppeteer is a female and the student is a male, the voice is automatically changed. This is all delivered across the web. And we do this now, I think there's 22 universities in the United States that subscribe to this service. And it's actually been, the underlying technology's been commercialized by a firm, which I cannot remember, or I would tell you, in San Francisco. Also built on game engines is a big move in the US for autonomous vehicles. And the state of Florida is interested in how will occupants react to autonomous vehicles, when you're inside one. So we have one that we run young and old drivers through. This is an ongoing piece of work. And this is somewhat portable, and we take it to other venues. So it's mainly oriented on human factors research and public awareness. But the interesting thing is that this project has also morphed in that there's a development that's going to be built in Fort Myers, Florida, where they're interested in autonomous vehicles being if you will, a sales point. So you could call up an autonomous vehicle to take you to the grocery store or pick your children up from school. And so we're involved with a developer. We're not going to build these things, but we've helped them issue a request for information to find firms that might be interested in building this. Also, we have a game-based system that we funded that was to teach women breast self-examinations, and to also look at using, in the lower right, to teaching, looking at using augmented reality instead of anatomy books to teach cardiovascular orientation. A lot of work we do is mobile and game-based. And the interesting thing about being a multidiscipline organization is we spin the technology off and on. We take some, we do it for the military, we then take it and do it for other people. But I wanted to circle back around in the remaining time and talk about this ecosystem. I'm a real believer in this thing. So in Orlando, we have a game-based modeling, simulation, and training ecosystem. Who's part of it? The federal government. We're fortunate in that in Orlando, we're co-located with the Army and the Navy's training organizations, and they buy several $1 billion worth of computer-based training equipment every year. And they're very interested in game-based technology because it will save them money. So there's federal interest. Also, Federal Law Enforcement Training Center, which is in Georgia, has people in Orlando who are interested in harvesting this stuff. So, I mean, this is a great thing for a university. We have an outlet. We have multiple outlets for our research work that will progress it past what we can do right in our own backyard. Academia. Not only is my organization multidiscipline, but we work a lot with other universities. Not only universities in Florida, but universities wherever it makes sense. Local schools. We have there's a person that has reached out to local high schools so that kids who are interested in game-based and science, technology, engineering, and math can come to our institute and learn some of it and see how things might work in the real world. I might mention too, in academia, that at least at our university, there's several outlets for people interested in serious games. We have a digital media program where students can get a bachelor's and master's degree. We have the University of Central Florida also has a Florida Interactive Entertainment Academy, which is a graduate program that really was stood up. Electronic Arts has a large, several hundred game developers in Orlando, and they were interested in a pipeline. So we have that. But also outside, and our institute, also outside of the university, there's a large for-profit, I guess, university called Full Sail. And they do a lot of work in training students in game-based systems. So my point is that there's a large academic, local schools, healthcare organizations, several hospital systems have stood up simulation centers and are interested in using game-based systems to train staff. Theme parks are interested in this technology, and we interact and occasionally, I will say, separately with the theme parks. They're very proprietary about what they do. You know, Disney doesn't want Universal there, and vice versa. So we talk to them usually individually. And then video game manufacturers. It's important for universities to place their students. So that's kind of a once over on this ecosystem that exists in Orlando. So, but I also talked about a business case. You know, you want this technology to move forward. So at the university, we were funded by the National Science Foundation for a thing called I-Core. And this is a unique program where faculty members and students get training on how to take what work they're doing and build a little company around it. There's also what we call Small Business Innovative Research, and it's a technology transfer program that various branches of the U.S. government offer, and we help facilitate people at the university making proposals to that to build a business. In the paper I wrote for this conference, there's a large conference/trade show that the military has every year called the Inter-Service Industry Training Systems and Education Conference. It's always in Orlando and typically hosts 15 to 20,000 delegates. There's a serious game challenge there. And nobody gets paid for doing their serious games, but different groups, including groups from our university, but all over, can compete in the serious game challenge, and a couple companies have formed as a result of this. When Bill Clinton was president, there was a program instituted called Advanced Distributed Learning, which seeks to specify learning modules like software modules that you can build on top of games. That program is based in Washington, D.C., but has a large contingent in Orlando. And so there's research work done. The EU has programs, and I'm sure there are others. So, but my point is that there are avenues that to pursue to make a business case to move serious games from the laboratory to mainstream. In Orlando, we also have a group called Team Orlando, which is a unique combination of the university, leading military and simulation organizations, because again, they're a big player in Orlando, and business. So they meet once a month, and talk about moving technology back and forth, and gaps that exist. So when I extract this and I say, well, you know, I'm talking to you all, and you're all from different places, I don't know what you might look at. So a sample of a serious game ecosystem is the large bullet is program managers, developers, programmers, subject matter experts. This is your core. And that you reach out to focus groups, evaluators, business and legal people, and marketing as your work progresses. And these can be tiered, much as the social event last night, at least from a selfish point of view, allowed me to interact with many of you. You know, I'm kind of in the big bubble. I'm not a business person. But to understand what some of you were doing in your laboratories, you know, there's a tier of these things. So we have that in a small ecosystem in Orlando where I can interact with people at the Florida Interactive Entertainment Academy or in the digital media program or other departments. Because everybody's kind of doing their own thing. And I think it's important that the core be kept a manageable size. You can't have large groups of people, at least where I come from, typically don't get much done. So what kind of developments are on the horizon? Alan mentioned I'm really interested in truly massively multiplayer online games where we don't do sharding and we don't play all these games that game developers play to keep the system manageable. So I have a project that's just going to start now on using supercomputers to look at how much we can load a system down and keep the computational load manageable and spool off within the computational system. Interoperable gaming. Too often now we build things and it goes for one purpose and it doesn't interact with other gaming systems. For over 20 years I've been a big proponent of at least simulations for trainings being interoperable. regardless of the cost, these things are expensive to somebody. So it'd be nice if that we could have some data structures that allow them to talk to one another. Transferable content. The Advanced Distributed Learning Program, that's what they're interested in. SCORM is a shareable content object reference model, so that you can move content around between systems. The healthcare community is also really interested in this. There's a group from Johns Hopkins that works on this. Augmented mixed reality games, more Pokemon Go's for more serious users. We need to keep this stuff engaging. Readily available personalized avatar through 3D scanning. We've just started doing this, actually for the military. They're interested in a soldier getting trained, but seeing him or herself as an avatar where it looks like them. So we have some techniques where we can quickly, but we'd like to be able to do it even quicker, have a personalized avatar that looks like you. Automated or customized tutoring systems. Different people learn in different ways, and we'd like to be able to, on the fly, pick up what they're doing and modify the delivery as we go. Exploitation of biological senses. Magic Leap, which is a company in Fort Lauderdale. I don't know how many people have heard of them. It looks pretty cool. We don't know how it works. They're very closed about it. But exploiting what we are as humans and alternate display modalities. We've just started some work on dynamic holographic displays where the content, a holographic model, can move. Moving forward, one suggestion, my suggestions are be opportunistic. If you find something that you think has relevance or promise, jump on it. Create, exploit, and embrace new technology. This is that cultural thing, because I'm an old guy, and so there's certain things that don't interest me, but it's important that I work to be open-minded, because the next this is a moving timeline. I always say, go where they go. Oftentimes I found we were doing a lot of work for the military, and we were interested in healthcare, using simulation for healthcare, but we would go to military conferences. And I remember telling folks, go where the doctors go. Go to their conferences. If you're interested in serious games for education, go where the educators go. Cross-fertilize engagement with colleagues. I think it's extremely important. Many times universities, at least in the States, are silos. And I think it's important that we keep an open mind and engage other disciplines, even that we might sometimes disagree with. Build organizational relationships outside of your organization. And create a manageable, serious ecosystem that's modest but grows. And every now and then, sit back and assess how you're doing. So in conclusions, I think serious games have made great progress, but there's more to do. Moving forward, we must have a compelling reason to build these things. It's been easy for the simulation world. Is it safety, efficiency, cost? Address cultural, business, and validation issues in use. One difficulty, I was talking to somebody about why are serious games in metropolitan Orlando not used that much in schools? And it was the teachers don't know how to use them, and they're unsure if they're validated. So somebody's going to put their child who's been learning a certain way. We talked about this last night. And now somebody's going to put something new. My goal is to have my child educated. And it's hard to build customizable ones for this school and this school and this school. There's organizational inertia to overcome. I've been doing it this way for 10 years and it's worked. Why should I change? And the innovator's dilemma, which means I've built a business around textbooks. Why do I need to, I have people who still want textbooks. How do I move the paradigm? And failure. So those are things we need to be sensitive to and try to overcome. And from a selfish point of view, universities can be really helpful in that. So expand our community of interest, inclusion of related disciplines, collaboration across venues and organizations. That's why I was so pleased to be able to come here to this group. And we need more real success stories to convince society that we're doing the right thing. So let's continue expanding our serious games community. And that's it.